Good morning, dear students. So this is Dr. Sridhar taking class for Bsc Mathematics, and my subject is Mathematics. Yesterday I have given the syllabus for Bsc first semester, and today I start the class with Unit 1, that is polar coordinates. So here, what are polar coordinates? So you know about the Cartesian coordinate system. Okay, so in Cartesian coordinate system, why we use Cartesian coordinate system? So it is used to locate a point P in a plane. It is used to locate a point P in a plane. So there we take two perpendicular axes, those are called as x-axis and y-axis, right? And then any point P in a plane is recognized by the two coordinates, that is one on x-axis and another one on y-axis. So the polar coordinate system is also another system of locating any point P in a plane. in a plane. Okay, so here what we do, let P be any point in a plane. Let P be any point in a plane, in xy plane. Okay, so then let O be the origin. Okay, O be the origin. Next, join O and P. Join O and P. Okay, here we join O and P. This is O and this is P. Join O and P. Then let R be the length of the OP. Let R be the length of the OP. In figure we see this one. This is R. R be the length of the OP, and theta be the angle which OP makes with positive x-axis. Now see here, this is line OP. OP is making angle theta. Here it is theta. Theta with x-axis. With x-axis. OP makes an angle theta with x-axis. So then here the R and theta. Okay, here R and theta, they are called as polar coordinates of the point P. So with the help of these R and theta, we are able to locate a point P in a plane. So therefore R and theta are called as polar coordinates. Okay, so here R is known as the radial distance. R is known as the radial distance, and theta is called as the polar angle. Theta is called as polar angle, and O is called as the pole, and x-axis is known as the initial line, and the OP is called as radius vector. OP is called as radius vector. Okay, so now from this figure, now see here, this is a right angled triangle OP, and this is a right angled triangle. Okay, so from this right angled triangle, then tan theta can be written as opposite by adjacent. Okay, so that is tan theta is equal to opposite is y and adjacent is x. So tan theta is y by x. So theta is what? Theta is tan inverse of y by x. Tan inverse of y by x. And similarly here in this triangle, R is known as the resultant vector of x and y. Okay, so therefore, or in other words, we can apply Pythagoras theorem. By applying Pythagoras theorem here, R is OP is equal to what? OP is equal to square root of x square plus y square, or OP is nothing but R. R is the square root of x square plus y square. And similarly, to satisfy this equation, we put x is equal to r cos theta and y is equal to r sin theta. So these are the which we use to satisfy this equation. Now in this here, the equations 1, so that is r is equal to square root of x square plus y square and theta is equal to tan inverse of y by x. These are the transformation coordinates. So it is used to convert into polar coordinates when Cartesian coordinates are given. Okay, we want to convert a Cartesian coordinates into polar form. These equations will help. Okay, and here x is equal to r cos theta and y is equal to r sin theta. So these are equations used to transform from polar coordinates to Cartesian form. When polar coordinates are given, then we want to convert into a Cartesian form, then we use these equations. Is x is equal to r cos theta and y is equal to r sin theta. Okay, so this is about polar coordinates. Next we derive the equations for angle between the radius vector and the tangent. Okay, angle between the radius vector and the tangent. So let us see this figure. In this figure, this r is equal to f of theta is a curve. Okay, or it can be denoted by c. So this is a polar curve that is given by r is equal to f of theta. Next, this is a point P on this curve. This point P is on this curve. Next, through this point P, we draw a tangent. Okay, through this point P, we draw a tangent such that it touches the x-axis at the point T. At the point T, here it is T, right? Then this is the tangent. This is the tangent, and this is the x-axis. Okay, and this is the x-axis. Now this tangent makes an angle psi, here psi, with x-axis. So this is known as angle between the this is known as the tan psi. Okay, now here OP. Now see here, this is OP. Okay, OP. This is known as radius vector. This is known as radius vector, and this is known as the tangent. This is known as the tangent PT. PT is the tangent, OP is the radius vector, and these two lines, that is OP and PT, they will intersect at this point and they make an angle phi here. And they make an angle phi here. So this phi is known as angle between the radius vector and the tangent. Okay, so now this is about angle between the radius vector and the tangent. Now we derive the equation. What we do, we consider a point P in a polar curve, r is equal to f of theta, and let PT be the tangent to the curve meeting the x-axis at the point T. Let psi be the angle which PT makes with the positive x-axis, and let phi be the angle between the radius vector and the tangent. And phi be the angle between the radius vector and the tangent. Now, to derive the equations, we know that x is equal to r cos theta and y is equal to r sin theta. Next, we know that from PUC, that is slope of the tangent is denoted by tan psi, or in other words, dy by dx is equal to tan psi, right? So this is equal to, now here dy by dx is equal to tan psi, or which is equal to, now psi is nothing but, in this figure, this psi is, from the geometrical concepts, this psi is nothing but exterior angle, and always exterior angle is equal to sum of the interior angles. Now here this is theta and this is phi. These are two interior angles, and so therefore here this is psi is an exterior angle, so exterior angle is equal to sum of the interior angles. So therefore what we do here, we replace psi by theta plus phi. So psi is equal to theta plus phi. So now to find dy by dx, as we know that both x and y are functions of r and theta. So therefore, so dy by dx is equal to dy by d theta divided by dx by d theta. Correct? So first we determine dy by d theta and dx by d theta. So now here to determine dx by d theta, now here x is equal to r cos theta, so differentiate this x with respect to theta. Okay, so then what happened, dx by d theta is equal to, so here we apply product rule. So first function as it is, cos theta as it is, then differentiate r, will get dr by d theta, then plus second function as it is, that is r as it is, differentiation of cos theta is minus sin theta. Similarly, take y is equal to r cos theta, then differentiate with respect to theta. So dy by d theta is equal to, then first function sin theta as it is, differentiation of the first function, that is dr by d theta, then plus second function r as it is, differentiation of sin theta is cos theta. Okay, So like that we obtain dy by d theta and dx by d theta. So now we find dy by dx. As we know that dy by dx is dy by d theta by dx by d theta. Okay, so here dy by dx is equal to dy by d theta divided by dx by d theta. So now substitute these dy by d theta that we determined here in this, and dx by dt is also here. Okay, so we obtain this equation. Okay, so now dividing this whole equation by dr by d theta into cos theta. So dividing the numerator by dr by d theta into cos theta and dividing the denominator by again the same thing, dr by d theta into cos theta. So what happened then? In this first term, if we divide this first term by dr by d theta into cos theta, so dr by d theta get cancelled. So sin theta by cos theta becomes tan theta plus, and here if we divide r cos theta by dr by d theta into cos theta, then cos theta get cancelled and we'll get r divided by dr by d theta. Okay, and similarly in this denominator, the first term is dr by d theta cos theta itself. When it is divided by itself, then it gives 1. So that is 1 minus r into, then here r into r divided by dr by d theta, then cos theta by sin theta becomes sin theta by cos theta becomes tan theta. Okay, so like that we get. So here, so dy by dx, after dividing we obtain this equation. So dy by dx is equal to tan theta plus r into d theta by dr divided by 1 minus r into d theta by dr into tan theta. Okay, so or in other words, dy by dx can be written as tan of phi plus theta. Tan of phi plus theta. This is because tan psi, dy by dx is equal to tan psi, and psi is nothing but sum of the interior angles, that is theta plus phi, which is equal to, now here we apply tan of a plus b formula. So it is tan a plus tan b divided by 1 minus tan a tan b. So after applying this formula, then we get, now compare this, call this equation as 4 and this equation as 3. Now compare these two equations. Okay, now compare these two equations. Now see here, every term tan theta is equal to tan theta, correct? Then here 1 is equal to 1. Compare these two quantities. 1 is equal to 1. Then tan theta is equal to again tan theta. But in place of tan phi, here we are having r into d theta by dr. Similarly, in the numerator, in place of tan phi, we are having r into d theta by dr. So this means that tan phi is equal to r into d theta by dr. Okay, so comparing 3 and 4, we obtain tan phi is equal to r into d theta by dr. So this is the formula for the angle between the radius vector and the tangent PT. So remember that always this phi, okay, this phi is nothing but the angle between the radius vector and the tangent. Okay, so now we solve some problems on this. So here the first problem is given. For a curve given in Cartesian form, show that tan phi is xy dash minus y divided by x plus y into y dash. Now see here, y dash means it is dy by dx. So now what we do, we know that psi is theta plus phi, because exterior angle is equal to sum of the interior angles. So psi is equal to theta plus phi. So tan psi is dy by dx, slope of the tangent, again which is nothing but dy by dx. It's denoted by y dash, it is y dash. So now also from figure we know that y by x is tan theta, because tan theta is nothing but opposite by adjacent. So tan theta is y by x. Okay, so now we know what is tan psi. So we know tan psi is y dash, and also we know tan theta. Tan theta is y by x. Okay, so now consider tan phi. Tan phi. So now tan phi can be is equal to. So from this figure, now here, from this figure, psi is equal to theta plus phi. Now phi means what? Here phi is equal to psi minus theta. Okay, so therefore here tan phi is tan into phi means psi minus theta, which is equal to, now here again we apply tan of a minus b formula. So it is tan a minus tan b divided by 1 plus tan a tan b. So according to this, tan psi minus tan theta divided by 1 plus tan psi into tan theta, which is equal to, now tan psi already we have determined, it is equal to y dash. So substitute y dash minus, and tan theta also it is equal to y by x. Okay, write y by x divided by 1 plus tan psi means again it is y dash, then tan theta it is y by x, it is y by x. So substitute all these values, substitute tan psi, tan theta in this equation, and we get, simplify, take LCM. In the numerator x is LCM and it becomes xy dash minus y divided by x, and in the denominator again x is LCM, so x plus y into y dash divided by x. So here x get cancelled and you will get xy dash minus y divided by x plus y into y dash. So this is the required proof. Okay, so next we take another problem, that is show that in the curve r is equal to a into e raised to theta cot alpha. So where alpha is constant, so remember here alpha is constant means cot alpha is also constant. Okay, cot alpha is also constant. So then the radius vector is inclined at a constant angle to the tangent at every point. That means the radius vector is inclined at a constant angle to the tangent means angle between the radius vector and the tangent is constant. We have to show that angle between the radius vector and the tangent is constant, or we show that phi is equal to constant. Okay, phi is equal to constant. So to prove this one, r is given as a is a into e raised to theta cot alpha. Okay, now differentiate this r with respect to theta. So what happened then? Differentiating, a is constant, so take outside a, then differentiate this with respect to theta. So e raised to ax differentiation is a into e raised to ax, right? So here also it is e raised to theta cot alpha into cot alpha is constant, so that is cot alpha. So a into e raised to ax, correct? So cot alpha into e raised to theta cot alpha, again which is equal to, now again in this equation a into e raised to theta cot alpha, from this equation it is equal to r. So here a into e raised to theta cot alpha is replaced by r into cot alpha as it is. So this becomes r into cot alpha. Okay, so this is, thus we get dr by d theta is equal to r into cot alpha. Next we find tan phi. As we know that tan phi is r into d theta by dr, that is angle between the radius vector and the tangent. Okay, so this is equal to, this is nothing but r into d theta by dr is nothing but 1 by dr by d theta. D theta by dr is equal to 1 by dr by d theta. So dr by d theta already we determined, that is equal to what? R cot alpha. So substitute here. So it gives 1 divided by r cot alpha. So r get cancelled and 1 by cot alpha is nothing but tan alpha. So we get tan phi is equal to tan alpha. So tan get cancelled, phi is equal to alpha, because alpha is a constant. So therefore angle between the radius vector and the tangent is equal to constant. Okay, so like that you have to solve the problem. So we take another problem. Find the angle between the radius vector. Okay, find the angle between the radius vector. Find the angle between the radius vector and the tangent for the curve r is equal to a into 1 minus cos theta. Also find the slope of the curve at theta is equal to pi by 6. Now remember here, slope of the curve means what? We have to find tan psi. Tan psi, this is the slope of the curve. Tan psi we have to find. To find tan psi we need psi, and psi is theta plus phi. Okay, so therefore first what we do, take r is equal to a into 1 minus cos theta. First we find phi. So differentiate this r with respect to theta. Now see here, dr by d theta is equal to, now a is constant, Now differentiation of 1 is 0. Okay, next minus, differentiation of cos theta is minus sin theta, that minus and minus becomes plus, so it gives a sin theta. So dr by d theta is equal to a sin theta. So now therefore tan phi is equal to r into d theta by dr, which is equal to r is nothing but a into 1 minus cos theta, then d theta by dr can be written as 1 by dr by d theta, and 1 divided by dr by d theta is a sin theta, so that is a sin theta. So which is equal to again now a get cancelled, here a and a get cancelled. Now 1 minus cos theta is 2 sin square theta by 2. This is from trigonometric identities. 1 minus cos theta is 2 sin square theta by 2, and divided by sin theta is again 2 sin theta by 2 cos theta by 2, half angle formula. Okay, so then this is equal to, now in this again 2 get cancelled, 1 sin theta by 2, 1 sin theta by 2 get cancelled, and in the numerator we left with 1 sin theta by 2, and in the denominator we left with cos theta by 2. So sin theta by 2 cos theta by 2 gives tan theta by 2. So tan phi is equal to tan theta by 2 we obtained. So here again tan get cancelled, so phi is equal to theta by 2. Okay, so now we got phi. Now we find theta. Okay, so now here to find the slope of the curve. Slope of the curve is psi is equal to theta plus phi. Psi is equal to theta plus phi. Now in this case, theta plus, substitute phi value. So phi value is theta by 2. Phi value is theta by 2. Now here phi value is theta by 2. Psi is theta plus phi. Phi value is theta by 2. Substitute. So psi gives, and simplify this, theta plus theta by 2 gives 3 by 2 theta, or dy by dx is equal to tan psi. So tan of psi means 3 by 2 theta, so 3 by 2 theta. So therefore slope of the curve tan psi is equal to tan 3 theta by 2. Tan 3 theta by 2. Now it is asked that to find the slope of the curve at theta is equal to pi by 6, right? So now in this case just substitute theta is equal to pi by 6 here. So what it gives? So tan psi is equal to tan into 3 by 2. Theta means pi by 6. So pi by 6 means 3 ones are 3 twos are cancels. It gives pi by 4. So tan psi is tan pi by 4. Tan pi by 4 value is always 1. So therefore the slope of the curve is equal to 1. Slope of the curve is equal to 1. Okay. So this is how we solve the problem. Next we have another problem. Show that at any point r theta, the tangent to the curve r raised to n is equal to a raised to n sin theta makes an angle n plus 1 into theta with initial line. Now see here, this is what we have to show. We have to show that the tangent to the curve, okay, to the curve makes an angle with initial line. Means angle between the tangent and the initial line is nothing but the psi, that is slope of the tangent, that is psi we have to find. Okay, so to find psi, what we need? We need theta and phi, because psi is equal to theta plus phi. So we need theta and phi. Okay, so therefore first we determine phi. So here in this case it is given r raised to n is equal to a raised to n sin n theta. Now differentiate this with respect to theta. So r raised to n differentiation is n into r raised to n minus 1. Again differentiate r by applying chain rule. It gives dr by d theta, which is equal to a raised to n. So here n into a raised to n, because a raised to n is constant. Then differentiation of sin n theta is cos n theta into n theta differentiation is n. So d theta by dr gives, reverse this one. So n get cancelled, then r raised to n minus 1 bring here, simplify this, and you will get d theta by dr is equal to r raised to n minus 1 divided by a raised to n cos n theta. So therefore tan phi is equal to r into d theta by dr. So now substitute this d theta by dr here. So we have determined this d theta by dr, substitute this value here, which gives, and simplify, r raised to n by a raised to n cos n theta, or r raised to n is nothing but a raised to n sin n theta from this equation, a raised to n sin n theta. Then a raised to n get cancelled, sin n theta by cos n theta gives tan n theta. So here tan get cancelled, and phi is equal to n theta will give. So thus for the curve phi we obtained as n theta. Then now psi is equal to, we know that we have to find psi, the value of psi we have to find, and we know that psi is equal to theta plus phi. Okay, here now in this case we substitute phi value, that is n theta here. So theta plus phi means n theta, which is equal to, now take theta common and you will get n plus 1 into theta. So which is required, we have to show that the tangent to the curve makes an angle n plus 1 into theta with the initial line. So this is the required condition. Okay, so next similarly another problem we have, prove that the normal at any point r theta on the curve r raised to n is equal to a raised to n cos n theta makes an angle n plus 1 theta, so with initial line, Okay, so again here same thing, you have to take the curve r raised to n is equal to a raised to n cos n theta, differentiate, find phi. Okay, then differentiate with respect to theta, then find out d theta by dr, then find tan phi, then tan will get cancelled, then you will get the phi value. Okay, then psi is equal to theta plus phi, substitute here and you will get again n plus 1 into theta plus pi by 2. So from this equation the angle between the normal and the initial line is phi minus pi by 2. Okay, so now here already we have determined psi, this one, and subtract pi by 2 from this equation. So that is what psi minus pi by 2, which gives n plus 1 into theta. Okay, so this is how we solve the problems using the formula of radial and converger. So next, and try these exercises, try these problems, so and try to solve these problems. Okay, if you have any doubts, then afterwards we clear the doubts. Thank you.